Hello everyone, welcome to lesson 1-5, Negative Exponents. Real world link, insects. The table shows the approximate wing beats per minute for certain insects. Okay, so what they're trying to say is, when they say wing beats, is how many times the wings will be flapped per minute, right? So here we have a table. Here we have our insect, we have a house fly, just your regular fly, and a small butterfly. Wing beats per minute, how many times does the wing actually flap or beat per minute? 10,000 times in 1 minute a fly will flap its wings. And a small butterfly will do it about 100 times. Okay, obviously these are estimates because to get that perfect of a number is actually not possible. Let's see here now. Write a ratio in simplest form that compares the number of wing beats for a butterfly to a housefly. So it looks like we're writing a ratio, right? We're writing a ratio, we're comparing. If I were to write it, I could simply write, for example, the butterfly has 100, right? While the housefly has a 10,000. Now this could totally be simplified if we were to cut some of these zeros down. Now, if I were to do it just by simply taking out 0, if I take a 0 here, I have to take a 0 here. If I take a 0 here, I take 1 here. And what am I left with? I am left with, on the top, 1 to 100. Do you see it? Right? 100. This is a comma, by the way. We put a comma every 3 place values. So for every one time that a butterfly flaps its wings, the fly will flap it 100 times. Write the ratio as a fraction with an exponent in the denominator as a decimal. Okay, so now I'm going to write it 1, and 100 can be written with an exponent as 10 to the power of 2. 10 to the power of 2. Now, they're asking us to write it as a decimal as well. 100th can be written as a decimal as 0.01. So now you can see how when you have an exponent, right, you write it as a decimal. If you do not want to write it as a fraction, we would write this as 10, like this, 10 to the power of -2. All three of these, boys and girls, 10 to the power of -2, or 1 over 10 to the power of 2, or 0.01, all three of these are saying exactly the same thing. They're all giving us the exact same value. And now that we know that, we can practice by completing this table. Okay, so number 3 says, complete the first 4 rows of the table showing the exponential and standard forms of power of 10. Okay, then for number 4, what operation is performed when you move down the table? We'll address that in a minute. But we have exponential form, meaning you write it with an exponent, and standard form means you actually write the number. Now remember the trick that I taught you in class. You simply write the 1 when you're writing in standard form, and the exponent right there will tell you the number of zeros. 1, 2, 3. Right? Or the other way around. Over here we see that we have 2 zeros, so we put 10 to the power of 2. Over here we only have 10 to the power of 1, so we put our 1 again, and how many zeros will we have? Only 1, because it says to the power of 1, right? But 10 to the power of 0, how many zeros do we have? Well, it's telling us we have none. And there we go, that's why we have 1. And if we continue to go down, the number below 0 is -1. We have to write it like this, 0.1. Do you see that? Or we write it as 1/10, right? It's the same thing. 10 to the power of -2 would be 0.01. We keep moving the decimal over to the left, which would be 1 over 100, right? And one more would be 10 to the power of -3, which would be 0.001. which equals 1 over 1,000. If it helps, this is a little trick that I have. You see how we have negative 1? I have 1 0, and I go to the right. See how I have negative 2 to the power of negative 2? 2 zeros. Power of negative 3? 3 zeros. Now remember, the first 0 is in the units, in the ones. In order to move a decimal place to the left, over here you can tell that I moved it 1 to the left to get 100. Then I moved it 1 more to the left to get 10. Then I took that decimal and moved it over here and I got 1. And so on. You see that? I keep moving the decimal to the left. In order to move a decimal place to the left, I actually have to divide the number. I have to make it smaller. So what operation is performed when we look at number 4? What operation is performed when you move down the table? Division. So then if we divide, what happens to the exponent? What happens to the exponent? Well, when we divide, look at that, the exponent is decreasing in value, right? By 1, isn't it? Look, we're counting backwards. 3, 2, 1, 0, negative 1, negative 2, negative 3. So what happens to it? It decreases by 1, okay? It decreases by 1. All right, let's go on to the next page. Please make note of the key concept. So you can title it 0 and negative exponents. Words. Any non-zero number, so numbers that are not 0, to the 0 power is 1. So if I have the number, any number to the power of 1 is going to equal 1. But the base cannot be 0. So any non-zero number to the negative n power is the multiplicative inverse of its nth power. What does that mean? Well, if I have 10 to the power of 2, right, is 100, right? Oh, let's put that in. But if I have 10 to the power of negative 2, okay, it's the multiplicative inverse. You know that 100 is over 1, right? Now it's the multiplicative inverse would mean the reciprocal, which I just flip it around. So now it's 1 over 100. Okay? So here we have examples. 5 to the power of 0 is 1. Or 7 to the power of negative 3 is 1 over 7. 1 over 7 times 1 over 7. You see that? So it's 1 over 7 to the power of 3. Algebraically, we just replace the numbers with variable, and we have x to the power of 0, which it equals 1. X cannot equal 0, obviously, because you can't have a 0 with an exponent. And then we have here x to the power of negative value, becomes a fraction. And this is how we can use exponents to represent very small numbers. Negative powers are the result of repeated divisions. So essentially it's a fraction. And let's see how it's done here. Look at the example 1. 6 to the power of negative 3 is 1. Make it as a fraction. To 6 to the third power. Okay? And 6 to the third power would be 6 times 6 times 6, if you wanted to write it as an actual fraction. And over here you have a with an algebraic expression to the negative 5. It's 1 over a to the power of 5. Once we know what a is, we can solve for that value. Okay, if you think you got it, let's try a to d. Pause the video now and try it on your own, please. Pause now. Okay, number 1. 7 to the power of negative 2 is going to be 1 over 7 to the power of 2. Now we understand that. So now let's solve 1, and 7 times 7 is 49. So this is the fraction expressing 1 over 49, or 1/49. 5 to the power of 0, okay, is simply 1. Anything to the power of 0 is just 1. Okay, let's try B. Sorry, I jumped over to C there, but just for convenience, because it was right next to each other, or under each other. B to the power of negative 4 is 1 over b to the power of 4. We can't solve it because we don't know what b is. And m to the power of negative 3 is 1 over m to the power of 3. Simply done. Okay, now let's take a look at example 3. And for example 3, now we're going the other way. We're going backwards. Where we have write each fraction as an expression using a negative exponent other than negative 1. So here we have 1 over 5 to the power of 2, you know if you were to go backwards, this is 5 to the power of negative 2. 1 over 36, you know that 36 is a square root of 6, right? We just, you have to multiply 6 times 6 to get 36. So you write it as 1 over 6 to the power of 2, or 6 to the power of negative 2. Okay, let's try E. If we look at E, we have 1 over 8 to the third power, and that would be, if we have to write it as a negative exponent, okay, it would be 8 to the power of negative 3, right? B would be 2 is the square root. The square root of 4 is 2, right? So we could write it as 2 to the power of negative 2. Okay, I hope that makes sense to you. Because one more step between it would be this. If I just draw one more step between it, I would write 1 to the power of 2 to the power of 2. You see? And then as a negative exponent, it would be like that. Okay, let's try C. And C, G. I'm looking at the wrong letters. We have C to the power of negative 5. And finally, D, we have 27. 27 is cubed. It's a number that is cubed, which would be, I'll write it as 1 over 3 to the power of 3. Because 3 times 3 times 3 is 27. And then I can just simply write it as 3 to the power of negative 3. Okay, now let's take a look at example 5. One human hair is about 1/1000th inch in diameter. 1/1000, 0.001 inch in diameter. Tiny, right? Write the decimal as a power of 10. So remember my little trick that I told you? You count the number of zeros, and that would be your negative exponent because we're going towards the right, right? So just simply based on the trick that I taught you, you would probably write 10 to the power of negative 3, right? Well, let's see. There it is. But this is how you would write it. You write 1/1000 as a fraction. 1,000. Do you see it? And then 1,000, you can write it as an exponent. 10 to the power of 3. See? 1, 2, 3. 10 to the power of 3. And then as a negative exponent, 10 to the power of negative 3, because it's a fraction. There you go. Okay, if you think you got that, go ahead and pause the video and try letter I on your own. Pause now. Okay, based on the trick that I taught you, we could simply do this one by counting the zeros. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10, so I could simply write 10 to the power of negative 10. Let's see if that is the real answer. Okay, let's write it as a fraction. Okay, so I'm going to write that number. Okay, so now we have to write this as a fraction. My trick for writing this as a fraction is I would write this number literally backwards. I would write 1 and then write my 1 here with all of these zeros, counting those zeros, and we counted 10 of them, correct? So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks like it's 10 billion. Okay, and then we can change this to an exponent simply by counting the number of zeros, and we've already established that it's going to be, I'll write it here, see if I can zoom in so we can get more. Okay, 1 over 10 to the power of 10, right? And then we know how to write that as a negative exponent. It's just 10 to the power of negative 10. And there you have it. Please make note of this next key concept. Multiply and divide with negative exponents. The product of powers and the quotient of power rules can be used to multiply and divide powers with negative exponents. So we can use those rules that we've been using where we add and subtract exponents. So for example, here we have 5 to the third power times 5 to the fifth power. I have a positive exponent and a negative exponent. So what do I do here? I'm supposed to add, correct? So when I add my exponent, because it's multiplication, I have to add my exponent. I'm adding a positive 3 plus a negative 5, which is negative 2. So you have to know how to add and subtract integers. And we have now in the fraction 1 over 5 to the power of 2, or 5 times 5 is 25, 1/25. And here we have w to negative 1 to the exponent of negative 1, and w to the exponent of negative 4. What will we do with these two? Remember, we're subtracting, so we're subtracting negatives. 1 negative minus negative 4. What happens when we subtract negative? Okay. Taking away negatives. When we take away negative, we add, right? Take away negative, we add. So we have negative 1 and we're adding 4 to it. Negative 1, we add 4, we get 3. W to the power of 3. Okay, if you're comfortable with this, go ahead, pause it, and try it on your own. Pause now. Let's check J. We have 3 to the power of negative 8 times 3 to the power of 2. I can simply write it as 3 to the power of negative 8 plus positive 2 is going to be 3 to the power of negative 6, right? I'm going to jump ahead to C so I don't have to scroll around too much. We have n to the power of 9 plus n to the power of negative 4. So really I'm subtracting those 4, so I have n to the power of 5. Okay, oh, I'm just realizing something now. I can't go any further here because I have a variable, but I can go further here. You see, I can still solve for this. I can solve it as 1 over 3 to the power of 6, and 3 to the power of 6 is 3 times 3 times 3 times 3 times 3 times 3, if you caught that, which would be 1 to the power of, I had to do this on my calculator, 729. So remember, I multiplied 3 into itself 6 times, and it gave me 729. Continuing on. K, my base is 11, right? And I have to the power of 2 minus 4, right? 2 minus 4. I get 11 to the power of negative 2, right? Because I took more than what I had. Which is the same thing as saying 1 over 11 to the power of 2, or 11 squared, which is the same as saying 1 over 121, because 11 times 11 is 121. Okay, and now let's try M. M, I have B, my base of B, to the power of negative 4 minus, remember, when we divide, we subtract exponents, negative 7. Take away negatives, we add. So it's b minus 4 plus 7. We take away negative, we add. And that's going to be b to the power of 3. Okay, now it looks like all we have left is our our guided practice. We have a lot to do for our guided practice, so please make sure you look through it and you feel comfortable so that you're ready for class. If you do not feel comfortable with any of these questions, or you just don't know how to do it, please go back to the examples in the video and try to see if you can understand them the second time around. See you in class, everybody.